Hello, welcome to Yang Tutorial Part 2. In Part 1, we looked at various basic Yang statements, modules, data types, and how to basically declare data. Now, in this module, we'll take a look at some of the more advanced statements in Yang that make interesting data models, constraints, uniqueness, etc. First, we'll take a look at the must statement. Must is an important statement in Yang because it allows us to express validation constraints right in our data model, which allows contd then to automate enforcement of these semantic validation constraints or relationships between data without having to write any code because it's precisely defined in the Yang data model using things such as the must statement. So must we see an example of on this slide where we have a access timeout and a retry timer. The retry timer has a constraint in our application that its values must be less than the value that has been set into access timeout. This is a semantic constraint. It's a relationship between data. So in the past, prior to Yang, we simply had to put this sort of constraint in our documentation and down in our software, but there was no way to express it just in a data model that someone could look at or a machine could process and understand the constraints. Must gives us that. So here in this example of must is a simple must statement. Current with the parentheses is a function that can be used from XPath. It refers to the value of the current node. So current gives us the current value that is in retry timer, and we have the constraint of it must be less than, and then an XPath, and that path / access timeout means we go up one level in our tree and then back down to access timeout. So the value in the current node of retry timer must be less than whatever is currently populated in the leaf called access timeout. If someone changes the value of either retry timer or access timeout, this constraint, as part of validation processing of the transaction, will be checked and enforced. If it's not valid, the transaction will not complete. With must, you can add things such as the error message attribute, which will be sent back, say, in a netconf reply or presented to the user in something like the CLI. As a Yang best practice, I do recommend that you insert a comment by your must statements stating the intent of the must statement. This will certainly help you or others understand the must statement, especially if you've had to use any complex XPath statement to help understand what is being said there. Here we have another example of a must statement usage. Here on our interface group name, we have a constraint that this interface group name must be different than the names of our interfaces. Elsewhere in our data model, we have an interface table with a list of names of all the interfaces in the system. Elsewhere in our model, we have this interface group name. There is a type restriction here, and then on interface group name, we have the must statement. So there's a path with a prefix to whatever module is prefixed by SYS in our model from its import. And here we have sys/interface. Then in square brackets allows us to select a node state. So off in sys interface, we look at the leaf called name in that interface list, and we're saying over in that system interface table, there must not be any name entries in that list whose value are equal to the current value of our node, i.e. interface group name. In contd, you will find an example in the example set that shows some various examples of must being used, as well as presenting various debug techniques for helping develop and test XPath expressions when used with contd. Here is another example of a must statement. Here we see the sum operator. So here we have configured into the system a max weight or metric for our interfaces. Each of our enabled interfaces will have a weight value assigned to it, but we have a constraint that there's a maximum weight allowed, or sum of the weight values across all the individual interface weights. So here we see leaf max weight can be set to a value from 0 to 1,000 with a default of 100. And then a must statement that refers over to the interface table. And for any interfaces who have a leaf called enabled whose current value is set to true, we will take from that list entry or row then the weight entry, add that into our sum. After we've summed that across all interfaces that are enabled, we check that against the value of the current node. Here we see a perfect example of why being able to state this precisely in our data model saves us development time. If you stop and think for a moment about what I just described, going to another table, searching through it for all enabled entries, and then only for those enabled entries, taking their weight values, taking their sum, and then comparing it to the current value. Think about how much code that would take you to write, whereas here we've expressed that constraint in one statement, and contd will automatically enforce this for you. Next, we have the augment statement. Augment is used to add to another data model or augment it. We have IETF standard defined models. We have other standard bodies defining Yang models. You may have other models within your company that you can't change. If you're using, say, for example, the IETF interface model, everyone expects you to be using the standard model. They expect you to not have made any changes to it. However, for the purposes of modeling your system, you may want to actually add something to that standards defined model. Augment allows you to do that. You can have one Yang module that you're not changing, another Yang module in which you use augment statements to add data nodes to that other module which you can't change. So here, if you'll remember from Yang tutorial part 1, we had an example of a basic user table of name, user ID, full name, and class of user. In our system, we want to take that standard user table and add an expiration date to that user information. So what we can do is we would have in our module have imported the module that has the user table under it, given it a prefix of SYS, and then in our module used the augment statement as you see here to say under system user, for that user list, augment it with this expire leaf. So you're adding this extra column to those rows in the user table by using the augment statement. Augment and some other Yang statements can also use the when modifier. When allows you to say, this should be there when some other condition is true. So here we have an example of, again, we're working with our user table that we had augmented in that expiration field. That expire is always there. It's in all entries in the table. But we have certain entries in this user table that now we want to add some login shell information. So any user whose class has been set to wheel, we also want to have the shell value present. However, for users whose class is not wheel, we do not want the shell to be present. So that is where the when modifier comes into play. Here we see augment system user when class equals wheel. So the leaf shell will only appear when wheel is there. Next, we have the choice statement. Sometimes in your data model, you get to somewhere in the model where you want, this or that to appear, but not all three. It's an exclusive or for what information should appear there. That is where the Yang choice statement comes into play. Choice says this can occur, or this can occur, or this can occur. You can have individual leafs and items, or you could have groupings or structures of items appear. Here, we see a simple use of choice. Our system has a transfer method. Two different transfer methods are possible: transfer interval or transfer on commit. They can't both be present, so we've modeled it as a choice, and then depending upon if someone shows, if it's an XML payload of netconf, if the transfer interval tag is there, the transfer on commit can't be there, and vice versa. In, say, entry into the CLI, they can enter interval or on commit, they enter one or the other, and that is what will be present in our populated data model. Now, sometimes when you're using choice, you don't have a case of a simple single data item like we saw with the threshold. Here we see an example of adding the case statement to the choice statement. In this case, we see a case called for counters. So we could have threshold, ignore count, ignore time, reset time. In the hierarchy of our model and our paths, for counters wouldn't actually appear. It would be counters / threshold, counters / reset time. Another alternative to using case is to do a container. So you could have maybe containers at that high level under the choice with entries. You can also state what the default case or contents of the choice should be by using a default statement on the choice statement. Next, we have the identity statement. Identity can be initially confusing when first used in Yang, and you may do a lot of Yang modeling and not actually find a use for the identity statement. However, it can be very useful in particular cases. So here we see an example of interface types. One of the places where identity is very useful is to give you an extensible enumeration. Normally, when you do an enumeration in Yang, when you declare that enumeration and its enum values, that is fixed. You can't change it, you can't add to it. Sometimes you have cases of you're doing modeling for different models of devices that you're making, and because of the differences in the model, you find some things like enums of, well, if I'm using my model set with device A, I want these enums, but if it's model C, I need a couple extra enums in there. That's where identity can come into play. You have, say, here in this example, the module physical interface has one set of identities. There's a base identity and then further identities that build on it. So in our main physical interface model, we have Ethernet, we have 1 gig and 10 gig Ethernet. Now we write a newer model for a newer device, but now we have 40 gig and 100 gig Ethernet available, but we can't go back for some reason and change physical interface and change its enums. It may break maybe other code that uses it or something like that. So in our module newer, we simply declare our new identities for 40 gig and 100 gig Ethernet, base that off of our existing Ethernet identity, and then later on are able to use that, say, on a leaf with a type identity ref. So ETH type in newer can take any of the values from physical interface or from newer, and so hence be Ethernet 1 gig, 10 gig, 40 gig, or 100 gig. But if something was using that Ethernet identity just from physical interface, they'd only have those base values. So identity you can think of as a extensible enum. Feature. Feature is similar to doing things such as if-def in C code. If perhaps you have a model, this data model covers 3 different models of devices that your company makes. But different models have different feature sets, and you want to use a common data model with particular features. So in that case, you define features in your Yang model using the feature statement, and then later on in your data model, you use the if feature statement to have certain things present. So here, our logging system, if our system has a local disk as a feature, then we have a buffer size that can be configured for the logging system. With contd, feature is implemented at compile time of your data model. In contd, you take your data models, run them through the contdc compiler tool to produce a binary format of the data model, which we call an FXS file, which is loaded by contd for use. So features are declared and happen at compile time of the Yang data model for contd. Very similar to using something like a pound if-def in the C programming language. Deviations. Yang has the ability for you to declare how my data model deviates from, or how my system deviates from a standard data model. So if you've taken, say, the IETF standard interface model, but your system somehow deviates some from that model, you can use the deviation and deviate statements in Yang. So for example, going back to our user table example, we've used some in this tutorial. If we went back, we would and saw the type of the user, type default value was something other than admin, and we really want it to be admin instead. So in some ways, this is similar to the refined statement that you can use on Yang groupings, but this is a deviation off another model. You're not pulling in the grouping, you're simply saying how you're going to deviate from that standard model. So we've looked at several Yang statements, and now we want to look at some of the strategies of how do we model with Yang. Again, I mentioned earlier, a good way of learning Yang best practice and how Yang models are done is to look at published Yang models from standards bodies such as IETF. If you go to the IETF website, various working groups are working on Yang models now. The NetMod, or NetConf Modeling Working Group, is producing several of the core data models as well. That can help you understand modeling strategy. So, one of the first things to think about is how do you model the constraints and validation limits for your particular system. Perhaps you don't want an onboard XPath parser. You don't have to, but it can help. You know, it's more formal and gives you a very nice, concise definition. Some of the constraint elements that can be used are things such as we see in the box in the lower right. How many elements can be in lists, leaf lists, uniqueness, leaf ref, must, when. So those are all certainly things you can do to model constraints within your system, because again, if you can precisely declare your constraints in the Yang data model, that can be automated for processing and can save you the time of writing and testing and maintaining source code that does it instead. Also, an important concept in network management theory is you need to avoid operational state dependent configuration. So it's very important to avoid that. So Yang in your hierarchy, if you've set something to config false, meaning it's operational state data in your Yang model, that inherits further down your tree. Once you've gone to config false, you can't go back to config true in that branch of the tree, because that would create operational state dependent configuration. Then you need to think about, how do you want to structure the data model? Do you want to just look at something and say, mimic an existing interface? How do you want to model that interface? Do you want to look at existing structures you have in your code? Do you want to look at it from the data entry viewpoint? Will all of the interfaces use a common model, or do you have some differing types of interfaces that are special, that some might be augmented, some might really need their own implementation? Do you want to have a model that drives the data of the system as seen by your applications, and then a different model that's used to drive the rendering of the presentation level to the user, and do a transformation between those different models? All of these are possible, but there is no one size fits all. It's going to be a matter of what works for the needs of your particular system. Also, namespaces are Yang modules. How do you want to decompose that? Do you want to try and stay in one really big namespace? Do you want to separate it out? There are, you've got to find the balance of the happy medium. Oftentimes can't just do one module or namespace for your model, because it just gets too large and unwieldy to work with. But yet, if you decompose it to separate namespaces and modules, you may get those to too many of them and too small, and you're juggling too many. You need to find that happy medium. Oftentimes people will, when they begin Yang modeling, start looking at feature sets. Like perhaps I'm doing a router, and so I'll maybe do a Yang module for each of my routing protocols for their configuration needs. So maybe I have a RIP model, an OSPF model, a BGP model, an ISIS model, etc. Also remember, you can't put configuration data under your operational data. Oftentimes, people will look at modeling a list or table of configuration information and a separate table of operational state data for, say, interfaces. You might have an interface list and an interface statistics list, and you simply, on your interface statistics list, use leaf refs back to the configuration table. With Yang, you can do something like how an interface is modeled in the interfaces MIB for SNMP, where you're mixing configuration and operational data in your list entries. You can do that, you can work with it, but oftentimes people find it cleaner to separate them. So you also need to think about, what is configuration in your system? Is it the factory default when the device is first turned on? Do you need to probe and see what boards are plugged in and what's present when the system boots, and use some sort of default values there? Do you want to be able to do some sort of pre-provisioning where you can enter configuration in your system and save it and make it active once some condition happens, such as the insertion of a line card in a chassis? Do you want to be able to support rollbacks of your configurations? All of these sorts of things you need to think of in terms of your modeling and how your system is going to work. It's going to be different in each case, but think about what is configuration in your system, and that will lead you to what you need to model for your Yang configuration. One thing I would caution you about is think about not just your device in isolation, but think about the needs of the management system that may be managing your system via, say, netconf, or think about the needs of service provisioning across the network. Don't think of your device in isolation. When you start thinking about your device as a citizen of the network, you'll realize things such as a device that does self-modifying configuration is not a really good idea, and that should be avoided. Say the management station sets something in your device, and then you go off and set 5 different values based on them setting that, and that's publicly viewable configuration. If the management station has been storing your device's configuration, they are now out of sync because your device did some automatic reconfiguration of itself without the management station knowing about it. So to help with full network configuration management, that sort of self-modifying configuration in a device should be avoided if at all possible. When working with contd, you will find in the documentation set a short manual that discusses this concept of thinking about how to implement things with contd and model them when working with management stations and doing things such as service provisioning in your network. Now, let's talk about versioning our Yang modules. Yang has built into it the concept of data model revisions because through the life cycle of our device, we will have new or different revisions of models as that device goes through its life cycle. So this has been designed into Yang from the ground up. We saw in part 1 of the tutorial, the header of a Yang module has a revision statement that declares what is the revision of this model. The Yang RFC 6020 in section 10 provides revisioning guidelines to follow when doing revisioning of your data models. These guidelines are not something that was just pulled out of thin air and invented. It is based on years of industry practice, especially learned back through the SNMP MIB days and the issues people found with the need to work with different versions of MIBs. Those sorts of lessons learned went into the revisioning guidelines for Yang models, and it is a highly suggested best practice to follow them. What will result when you follow revisioning guidelines is backwards compatible models. This makes the job of programming and the applications and instrumentation that work with the data model in your device more stable as a result of changing revisions. You're not breaking existing code. It also allows management stations to interact with your systems cleanly. In fact, with proper use of revisioning, it's possible for your netconf client and your management station to be built such that the operator of the management station isn't aware of the different revisions in devices out there in the field. They just see the model of the device, and your system takes care of speaking in terms of the right revision of the model to particular devices because it knows which ones it has from the netconf hello exchange. So, the guidelines for revisioning. You can add things. You certainly must add a new revision statement at the top of the module. I mean, certainly this isn't something you change that revision every single day during your development cycle, but as you release revisions of the module, that revision should be there. As necessary, update organization and contact information in the header of the module. You can't remove things or change existing things. So you can't rename the modular namespace. You don't remove obsolete definitions. There are ways of declaring them deprecated and obsolete in your model. You don't reorder data definitions. So if you had a Yang list, you don't move around things in it. You add new fields to the end of it, not in the middle. You see other things here in this list of things that you can add. You can add non-mandatory data definitions. In other words, if someone spoke to you in terms of the previous revision of the Yang model, you should still work when you follow the revisioning guidelines in the Yang RFC. Other things you may do. You can add a status statement to items in the model. So statuses go from current to deprecated to obsolete as guidance for users of the data model for fields they should or shouldn't set. You can do things like expand range and length restrictions on types because that's still backward compatible, etc. in the list here. You can change something that was mandatory true to now mandatory false. You can remove and relax min and max elements, meaning if previously max elements was 512, you could change it to be 1024, etc. here. Also, a best practice past revisioning properly your models is IETF does provide modeling recommendations through one of the RFCs. Some of the modeling recommendations for best practices are make sure that you properly document and describe. You've seen the description statement in the Yang through this tutorial where we've had short descriptions for the purposes of example. Use the description field. You cannot over-document a model. Certainly, provide references, definitions. In terms of organizing the module itself, they do recommend that you only have one top-level data definition of your tree in your module, i.e. like just one container at the root of it. It is legal in Yang, and contd supports having multiple top-level elements in your model, but for that module, if you have one top-level item, it's just one tree within that module. If you have multiple top-level containers, logically you really have multiple trees in there. You can do it, but especially when someone's looking through the module, if you have one top-level container, you always know right what tree you're in there. IETF, especially for if you're doing any Yang models that you are submitting for standardization, recommends the use of identity ref instead of enumeration, since enumerations are fixed and identities can grow and be expanded if someone's going to derive from your model. They also, suggest in the guidelines use of specific types. Make sure you use ranges, length restrictions, patterns. If you're going to declare something to be a integer and its values can only be 1 to 10, make sure you describe it as an unsigned integer. Make sure you apply that range restriction to it in order to properly constrict to valid values. Don't just say, this is an int 32, and then in your back end restrict it to 1 to 10. Declare it as an unsigned integer. Put in that range limitation in your model. Also, as much as possible, reuse standard type definitions such as those defined in RFC 6021. Don't reinvent equivalent data structures for something that already exists. People are used to using the standard ones, use them. Also, do things like create common modules for common reusable types within your data models. Something like company name -common.yang to put the type defs you commonly use across various Yang modules all in one place. So, let's talk a little bit more about other things in the Yang ecosystem, such as Yin and Yang extensions. I had mentioned previously that Yang has a XML counterpart called Yin. If for some reason you don't want to work with the standard Yang language, there is an XML equivalent. Or perhaps from your XML processing tool chain, there are certain tools that are useful for some reason in your development cycle. So within the Yang RFC, there is the definition of the XML equivalent, which is called Yin. So we see on this slide two equivalent data models for the Yang version and the Yin version. You can losslessly convert a data model from Yang to Yin, back to Yang, and result in the exact same data model you started with. That was designed in from the ground up. There is a tool called Pyang, Pyang, that's out there as an open source tool and also included with contd, which is a Yang parser that accepts pluggable backends. That one of its pluggable backends is a Yang to Yin or Yin to Yang converter. You can also extend Yang. Just like netconf is an extensible protocol that you can add new operations to, you can add new statements to the Yang language. Of course, if you create your own Yang statements, contd won't know about them and won't use them or process them. If you're defining extension Yang statements, therefore, your tool set to use if you're doing some in-house tooling. We'll talk about this on the next slide on how you could support that. But for defining extension statements for the Yang language, you use the extension statement. Here, we see a definition on the left of some Yang extensions. So we have a module, and in there we're creating three new statements: create, value, and key list value, and then also declaring arguments. When you look at definitions of extensions, you also can see things such as used in and some other extension statements that can be used there. In fact, if you're working with contd, if you look at the module tailf-common.yang, you will see extensive use of the extension statement there that is used by the tailf tool chain for processing. Here, for this example of these extensions of create value and key list value, on the right we see use of those extensions. So our module XYZ would have done an import of our prototype module, and then we can see here where we have this list called Y, which is a table of operational state data since it's config false, and then uses of these create statements. Now, prototype would have been the prefix we gave the model. Somewhere in module XYZ, we would have said import prototype prefix prototype. So you're able to use your extension statements, and typically they'll have that prefix since you've imported them in your Yang code. If you've done these sorts of extensions of your own, the contd toolchain will simply ignore their presence. It won't break anything. For you to process those extension statements, because you've defined them because you have some use for them, that is where the Pyang tool comes into play. Here on this slide, we see a logical flow. We've got the prototype.yang file, we've got our xyz.yang file. At the bottom, we see the contd tool, which is compiling XYZ into the binary format, or xyz.fxs, for use by contd. It will have ignored your extension statements from the prototype module, but where you can add processing for your extension statements is by making use of Pyang. Pyang is a tool which is a Yang parser written in Python that takes pluggable backends for controlling the output format. If you've ever used the tool SMEDump or SMIDump from the SNMP world, where that was an SMI parser and could take pluggable backends for different formats, Pyang is the equivalent in the Yang world. You can write plug-in backends that would process and understand your extension statements, and as the result of the output of running Pyang on your data model, it would do whatever you wanted for those extension statements to do. So, with that, through this tutorial, we've talked about individual items, statements, some little snippets. Let's try and pull this together more and look at a little bit larger model. Here we have some data model based on some modeling of the Quagga open source routing suite. Here we see some things such as a submodule definition called Quagga Common that belongs to Quagga. We see an include of Quagga top, some type defs. We see a grouping definition. We see a type def of a MAC address type with a length and pattern. And on the right, some additional type defs that we'll be using elsewhere in our model. Then now we'll see a couple other submodules that are pulled into this top level module. On the left, we've got some interface definitions. We see some includes of some additional submodules, a type definition that's only useful within this submodule, so we didn't put it in our common set of type defs. We see the use of augment. Somewhere else, since there's no prefix on here, it's in our parent module, somewhere above the submodule. There's an interface table that's modeled as container system list interface that we're augmenting. We're adding bandwidth, link detection, etc. into that model. On the right, we see an additional similar use where under system interface, we had an IP entry where here we're adding a list or table called address. There is an address and prefix length used for the keying of that table, and then an additional leaf in that list entry. Then some additional uses. Now, one of the things I'd like to highlight on this model on the left, you'll see the import of tailf common. Through most of this tutorial in both parts, I have been talking simply about standard Yang from RFC 6020. When using Yang with contd, you need to annotate your data models with some guidance to contd in regards to what annotation may be present in the system, what instrumentation is there. So here we see this import of tailf common, which you'll do in most of your data models when working with contd. And if you look down almost to the bottom, you'll see tailf : call point. That call point statement is an extension statement defined in tailf common that we need to use on this operational data item to give us an identifier which our instrumentation will register for. When we get into the modules of this video training series, which talks about writing code which interfaces with the APIs of contd, we'll talk much more about the various tailf extensions that come from tailf common, which you'll use in your data model in your system. On the right side of the screen, we do see also an example of a netconf notification definition. Here we have a notification called SA expired. It will have two output parameters included in the notification. These are like var binds on an SNMP trap. They've both declared to be mandatory. They must always be there. And also the tunnel name is a leaf ref to our VPN tunnel table. So if we're sending this SA expired notification, it's only going to refer to an existing tunnel name. So that is why We make it a leaf ref. Instead of just leaving it a string and expect our programmer to populate it, we can have this constraint modeled here. And one other example use case, other than these Quagga models, is a service model. Yang models don't have to just reflect the lowest level information of what physically exists. They can be used, Yang models can be used to describe more abstract concepts. I briefly mentioned earlier the idea of model transformation, where you maybe have a low-level model that drives the storage of your database and your instrumentation APIs, and a higher level or differently organized model that's used to maybe present and render your CLI. And you do have code that understands how to transform or map between those two models. So we can apply this same level of abstraction to things such as services. So we can have the idea of services across a network that we do a Yang model of, and maybe that is used up at our management station in conjunction with our device Yang models in order to do service provisioning across our network. We configure the service, and then something such as the TailF NCS product is used to map those services into the models of the individual devices. So here we see an example of modeling an abstract service. We use the exact same Yang constructs. There's Q&Q VLAN table modeled as a list. There's a name. We see a use of mandatory. We see a use of must in here because the VLAN must be unique within the network. So our list is keyed by name, but we have this uniqueness constraint on SVLAN, but it's not being tested for necessarily just within this table. You could have things such as a list of edge switches that those switches can only exist if they're modeled, say, in your device table, etc., through the rest of this model, just as an example of how you can model something at a more abstract level with Yang. So that brings us to the conclusion of Yang tutorial part 2. So between the two parts of this tutorial, you should have a good sound basis now in the Yang data modeling language and be prepared to start writing your own models. Thank you for sitting in on this module.